Hello, everybody. I'm not feeling well today, so I won't be at school, obviously. And I need to help you out with this practice test. I know some of you guys probably know how to do this, and you're really good at it. That's great. Some people need some help, so let's just do a few of these. I will have a key posted here eventually, but I do not have it ready yet, and it'll probably be of it tomorrow sometime. Okay, let's get started. So the first section is write the formulas. So we're going to write these formulas, and the way we're going to write these formulas is just using the ion chart. So we have copper 2 phosphate. So if you go into your ion chart and you find copper 2, which is right here. Copper 2 is Cu plus 2. I'm going to go back to my practice test, and I'm going to type Cu. Right. Then I'm going to use my arrow buttons, and I'm going to go into the front of the Cu, and then I will push return and go up one click, and I'll have room where I can write the charge. So there's copper plus 2. Okay. Now that's with a phosphate. A phosphate, look at that last name, it's 8. That's got to be a polyatomic ion. So you go into your ion chart, and you find phosphate in the polyatomic ion table right there, PO4 minus 3. So I'm going to go back to that, and I'm going to put in parentheses, because we write our polyatomic ions in parentheses, PO4. Make that a subscript, and then that's plus 3. All right. At this point now, it's where you crisscross. So take whatever number you have here, and you're going to put it down here. No charges, just the number. And whatever number you have here too, you're going to put down here. Again, just the subscript, not the charges. Okay? And there you go, copper 2 phosphate. All right, I'm going to pop down here and do one more in this section. This is iron 2 oxide. So I'm going to start with Fe. And let me go show you where I'm finding this stuff. I'm on the ion chart. There's Fe, and this is iron 2. So it's Fe plus 2. Remember that Roman numeral is the charge. So if you know the symbol, you don't have to relook it up because you already know what it's going to be. It's Fe plus 2. Oxide. Oxide is the ion version of oxygen. Let me move this picture. And it's right there. Oxygen is minus 2. So we write O minus 2. Okay, there's no parentheses here because this is not a polyatomic ion. All right, and it was minus 2. It's oxygen. Okay, now look what we have. We have 2 and 2. So we can put 2's down here, but we'd have to reduce it. And we'd have to reduce it down to 1 and 1. But when we have 1 and 1, we don't write the 1's anyway. So that one is actually finished. All right. Iron 3 sulfate. Okay, I just did iron 2, so iron 3 is Fe. I'm going to go in front of it, return up top with plus 3 charge. Sulfate. Sulfate again, it has a weird name. I'm going to check the ion chart. I'll check the polyatomic ion section. And sulfate is SO4 right here. SO4 minus 2. And so I write SO4. Now, polyatomic ion, put it in parentheses because it's easier to do that. And why not do it the easy way? And plus it looks cool too. And so that SO4 was minus 2. Okay, now we're going to crisscross. So we put a 2 here. Make that a subscript. And we're going to put a 3 right here. All right. And that is pretty much that section, okay? All right. Now those others will be done just like that, so, take your time and do it right. Next section. Next section, we're going to write the formulas, or write the names of the formulas. Okay, so we're going to write the names of these formulas. So when you do this, use your ion chart. It's the names right off of the chart. It's really easy to do. Nothing fancy, nothing special. Ca, you look up Ca, that's calcium. All right. F, now F is fluoride. So calcium fluoride, and that's it. No prefixes, nothing like that. Just write out what it has on that chart. And there we go. Let's do one with the polyatomic ion. Right here, Sr. Find Sr on the chart. Strontium, right there. So I'm going to write out strontium. And then what do we have? We have OH. So that is in parentheses, right? So that's a polyatomic ion. And we look in there, and what do we see? We have OH right here, hydroxide. Okay, so we write down hydroxide. Strontium hydroxide. All right. And that is all there is to that. One thing to watch out on this section is I did not put parentheses around the SO4 here, and there should be parentheses around it. Now, the real rule is if there's no subscript outside the parentheses, you don't need the parentheses, but you might as well write them. It just makes it easier to find. Okay? Moving on. All right, now we're going to name these compounds using the Roman numerals. And so this is where the Roman numeral is the charge of the positive. The easiest way to do this is find out the charge of the negative first. So this is CuCl. So I go to the ion chart and I see what the charge of Cl is. And Cl is -1. Okay, now I go over here and I say to myself, what does the charge of copper have to be to make this charge's total 0? And the answer would be +1. And so this would be copper 1 chloride. Okay, why is that not letting me click it? I hate when it does that. So copper 1 chloride. Oops. Let's make that the same. There we go. Okay, now let's go over to this other side. Now, it's also a copper chloride. I have their sister compounds, right? They're matching. I did that on purpose. So we have copper. Now this time, look what we have. We have 2 Cl's. So we have 2 -1s. And so we have 2 -1s. That means copper has to be equal to +2 to make it equal 0. So we have 2 -1s, 1 +2, and we end up with copper 2 chloride because the charge is +2. You have to watch out when you have polyatomic ions, or I should say, you have to watch out when they're being reduced. So SO3 has a -2 charge. Okay, and so we have 3 -2s. So 3 times -2 is -6. So what does Fe have to be to make it equal and opposite, +6? Well, 2 times +3 equals +6. So you have iron 3 sulfite. Let's look at the other one. Okay, right, SO3 is -2. There's 1 of them, so the Fe has to be +2. So our compound is iron 2 sulfite. All right, does that make sense? Now they'll be like that on the test, exact same way. Okay, let's go count the atoms. All right, so this section is really easy, right? We just count the atoms. So we have our aluminums. We have just 1 aluminum because there's no subscript there. Now this 3 is outside the parentheses, so that triples everything inside. So you have 6 C's. You have 3 times 3, which is 9 H's. And you have 3 times 2, which is 6 O's. And that's all there is to that. Okay. Finding the masses of the compounds. All right, I'm going to pick this one right down here, zinc phosphate, because it's a good example, right? So first of all, we look and see what the mass of zinc is. So zinc is right here, and oops, I'm on the ion chart. Zinc is right here, and it's 65. Okay, so go back in our test. And so we have 3 of them. So put in 65 times 3 plus we have P, and we have 2 total P's, right? So you look on your table and you see that P is 31. It's 30.97. We round out to 31. And so you have 31 times 2. Right, 2 times 1. Plus oxygen is 16. Again, I'm just getting these off of the table. 15.999 rounds up to 16. And so we put 16 times 8. And equal sign. Now, I don't have a calculator here handy. If you do this, if you type it in your calculator that way, it will give you the right answer. I don't calculate. I'll pump mine into to Google really quick. You will not be allowed to use Google for this on the test, so make sure you can punch it into your calculator. And I get 385. All right, so if you put it this form, it will go into your calculator that way. And that's the important thing. All right, now we're not going to put a unit on that right yet, so don't worry about that. Okay, prefix method. Now the prefix method's pretty simple to do, right? It's probably the easiest one. The first name is whatever the element's name is, the element's name. So if you look on the chart, the periodic table, that first name was iodine, right? Iodine, not iodide. That's the ide name. You want the first name has to be the regular name. So iodine. Now there's one of those, and you don't have to put the mono for the first thing. You have to do it for every other thing, but not this first thing. So if there's one first name starts, if there's one of the things with the first name, you don't put monoiodide or iodine. All right? And then our next thing is we have 7 fluorides, right? And then I see that ides. I'm using the ide name. So instead of fluorine, I'm saying fluoride. And so 7 is hepta fluoride. Iodine heptafluoride. Let's see. Well, I'm going to do this one right here. It's right here, right? So there's 2 nitrogens. So dinitrogen. And then pentaoxide. Now, let me do it the wrong way first. If you put it in like this, it's going to come up with a misspelling. And the reason is because this A gets dropped. And it's because you have 2 vowels together. If you click on that, it will fix it for you. See, the A's dropped out. If you want to just not worry about that kind of stuff and you want to put penta/oxide, you can do that too. So either way works fine with me. Okay? Last section, we're writing them out. So it works almost the same exact way. Let's do this one here. We have nitrogen, and there's 3 of them. So N3, right? There's nothing crazy about this. You don't have to use any ion charts because these are covalent bonds. You don't need ion charts because there are no charges. and then we have tetraoxide. So oxide is O, and tetra is 4. Yeah, the chart's up there, but it is 4, so okay, and then we do that, and it's done. Okay, so those aren't too bad either, and that's the last part of the test. So I'll put a key up. I'll probably send a key in tomorrow. Also, if you haven't finished, like if you're done with everything else, you're done with this test or whatever, and you haven't finished your guided reader from last chapter, you can do that too. All right. Hey, have a great day.